Okay, I would like to let you know. Okay, sorry. Bismillahirrahmanirrahim. I would like you to know that we'll be having our test one by next week, if I understand correctly, from our LIC, Madam Mazrato. So that means test one will be on chapter one and chapter two, and part of it will be the one that we'll be discussing today, lah, which is desktop energy audit, up until energy audit. So the one that I have explored back in last week, which is the early chapter 3, will not be included. It's only chapter 1 and chapter 2. And the format will be uh, 20 questions on chapter 1 and chapter 2 for multiple choices, A, B, C, D. And for subjective, will be more on sorry, subjective will be a combination of those two chapters. But basically, you will have around 22, 23 questions. Depend. Subjective, I'm not sure because subjective is under Madam Mazrato. So might be 2, 3 questions, but previously it's only 2 lah. But for multiple questions, MCQ, multiple choices questions will be done using Google Form. And that means you guys have to go to your Google Classroom, which I'll set up later. For your class, I guess for CACB, PABB, nothing changed. The same question. It's just that your Google Classroom will be assigned accordingly. CACB, sorry, I forgot. This is another class. I'm confusing with the other subject. But all of your class, I'll most probably distribute the markings to Cik Azri and also me. So depends. But basically for multiple choices question wouldn't be an issue because Google Form will mark it for me. So hopefully everyone is aware of that. Okay, apa lagi? So remember, next week is your test one. So before you plan for your holiday, for your mid-semester, make sure you study lah. And basically the subject is a theoretical subject, so nak make sure you know lah. At the very least, if you tak hafal pun, make sure you know where to look at and understand the subject. So as you know, we as a lecturer have no control over you discussing or opening a book to apa ni, to answer the question. So that means our questions will be more on application or understanding, not so much as direct question like what is this. No, most probably will be elaboration. So if you think that by reading a book or opening a book while doing the test, most probably it will not be sufficient. So nak tak nak kena study jugalah. Okay. But it's more on understanding. Okay, so let's start with our class. So make sure everyone turn on their camera so that the record shows that everyone is participating in the lecture and not just me babbling about alone in front of the camera. Make sure to turn on your camera. I understand girls may need some time, but I expect boys especially. I'm waiting for you guys to turn on your camera before I start. Okay, one, two, three.
Sir, saya nak tanya.
Yeah.
Test tu hari apa Rabu
To be determined, because most probably will be doing with the same time with the other classes.
Oh, okay.
So most probably at night, but exact day tu nanti saya announce.
Okay, sir.
Alright. Okay, only a few of you. 1, 2, 3, 4, 5, 6, 7, 8. Alright. Okay. So at least most of you has already turned on the camera. So we'll start. So so for today we are going to continue. If I'm not mistaken, Azri pun dah sampai previous one, which is kick-off meeting. He informed me. So I guess we continue with desktop data calculation lah. So desktop data calculation, basically what it meant is you not going to the site before preliminary data collection before you going to the site. This is to allow minimal time being spent at site. Okay, why we need to minimize our sorry. I put my iPad here, but suddenly let me rearrange my desk. Okay, give me a second. Like this. Think this. Okay, all right. So okay, continue. Why do we need to reduce our time at site? Because first and foremost, exposure to this extended exposure inside may cause unnecessary risks such as safety, uh, time allocation, and also human resources lah. And also of course capital in terms of money and cents, because the more you are at the site for auditing or data collection, the more you will interfere with the process of the manufacturing or whatever work that is being done by the technical person over there. So as best as we could, we'll try to minimize our time. Even though data collection is important, but we try to minimize our time at site. Uh, and therefore, it's best that we uh, it's best that we maximize our time off-site, meaning not at site and remotely if possible, and collected available data if possible from their records. Of course, still you need to validate the record whether the data collected is actually uh, accurate. So still a site visit may be required, but just for the sake of proving that the data is actually accurate. Not so much as collecting the data from A to Z. So that's why before we go to the site, it is advisable after kickoff meeting for us to conduct desktop data collection. It can be in the forms of drawings from their filing cabinet. It can be their historical electricity bills, it can be whatever data that you might require, floor plan or whatever. Try to get it before you go into the site so that you can reduce the time required to be at the site. Because again, I have being at the site, most probably the technician will need to stop their work. The machine will not will may need to the machine person, the machinist. Or I can't recall the technician or whatever will need to address you and therefore take their time off or from doing their work. So might not be preferable lah by the top management. So that's why we need the data collection. So again, as being explained in the words here, is to minimize, the keyword here is to minimize field energy related data collection by using all available facility data. All available facility data meanings any kind of drawings, any kind of data, any kind of bills, receipt or whatever that you can get it from off-site. Try to get it first before we go to the site yourself. Okay, it is advisable for you to use facility detail audit form being provided by Suruhanjaya Tenaga to help you to better understand the planning stage. And some of the things that you could gather off-site is basically diagram lah. Diagram, system drawing, design manuals, control system and whatever, and also electricity bills. So that is what it meant by remote desktop data collection. And then after you have done, you've already gained the desktop data collection, and you deem that site visit may still be required, and of course you still need to be you still need to do your field data collection to validate the data that you have collected to make sure that it is I mean there is no new machine being installed without maybe the drawing haven't captured or something. So you still need to go to the field data lah, to collect. So there are tons of steps here, but basically what it meant when you want to do field data set is first, of course, once you have identified what you want to measure, then you measure it directly, the selected parameter that you want to measure, and then the advisable next step would be to identify possible energy saving, whether it's feasible or not, and then analyze whether if the energy saving that you have identified could be feasible for your client or not. Because if there's no point of you proposing a huge investment in energy saving, but the company just want to I mean the solution that can be achieved by the regulation 16 is only by scheduling. So there's no point for and then the company is just a small company. Chances are they won't have the capital and they won't want to commit to extra capital needed required to achieve next stage of energy saving. So be feasible, So of course you have to analyze what kind of proposal that you might want to introduce to the client, and then and so on and so forth lah. Basically measure, analyze, and then once you got the data, make sure it's clean. All the NA variable you have to fill it up, and then typical data cleaning process lah. If you're involved with AI, chances are you're quite familiar lah with data cleaning process, especially for those data scientists. I'm not sure business school are familiar with that or not, but if some of you might have explored into accounting or the statistics, typically statistics would be familiar lah with data cleaning process. I think even if you're not, if you haven't learned on statistics back in high school, you should have already explored accounting, if I'm not mistaken. Even if you're business graduates, I'm not sure. I'm not up to date with the latest syllabus, but coming from science technical, yeah, I did learn what you call that, accounting back in high school. So my syllabus might be different than yours because I'm significantly. Our generation, our age gap is quite significant, I guess. So might not be applicable to you lah. But in case you are not familiar with data cleaning process, basically the data that you've gained, typically the plot might be dirty in the sense that you can't make sense if you just use it raw. You have to process it in this such that any kind of value that has not been captured, for example, typical lah, if you're using any kind of sensor, any kind of data measurement, data logger, whatever, there will be circumstances where some of the data has been lost and it will show NA, not available. And sometimes it can even be quite significant. So you might want to discard that kind of data to avoid any kind of reading error lah from your proposal later on. So and also reducing mean zero, instead of starting at zero, the data start at maybe 10, 15 kilowatt hours, for example. So you don't want that, because that would be that is actually typically error by the calibration, sensor calibration lah. So what you can do is remove mean zero, and some other steps lah that you can do for data processing, basically to make the data as clean, as easy for you to process as possible. So that is what is meant by clearing and apa ni lah, clearing or cleaning the data before you analyze the exact actual data. And then once you have done all the analyzing, you need to meet up and get the feedback from the top management, and then do some correction lah, if they require you to do some correction and get back to them. So all the other intermediate parts there, it's more on filler that you can read yourself. But basically, that's the main progress that I would like to highlight lah. Basically, you measure, you identify a possible energy saving, and then analyze whether that energy saving is feasible to the client. I think this is the main, I would say the main steps lah for field on-site survey punya data collection. And then dapatkan data, measure the data, make sure it's clean. We call that, as a data scientist, as pre-processing, data pre-processing. And then analyze the data, get the record, make sure it's tally, and then get the feedback from client, whether the data, because the feedback is quite important before you come up with a proposal. It's because to make sure that the data that you've gained, you understand the process correctly, because there are chances and circumstances that sometimes the data shows, for example, the data shows significant equipment not being used at that particular month, for example. It turns out they were conducting a shutdown procedure to maintain the machinery, which is good, but it would affect your energy reading lah for that company, which is not good. So if you know that, then most probably you can discard that month punya reading lah. So because it's falls under false energy saving, because it's not being used due to the fact that maybe there's no order, they're doing maintenance, maybe that month is what do you call that, a holiday for them, so they don't do their work at that particular month. Biasalah kerja company tu, kalau satu bulan tak kerja, seronok lah kot. Or maybe macam tahun ni MCO, so that data will not reflect the actual or the normal data consumption, electrical energy consumption for that particular year. So kena buang lah, data tu tak boleh pakai. Sebab nanti kalau pakai, chances are akan kacau all the other readings lah. Okay, so that's the importance of understanding the data. So feedback meeting with the company is more on getting to understand the data, to make sure there's no incorrect value being included. Okay, so these are the proposed list of activities, and the main one are the one that I've just said. The other ones is more like you boleh baca sendiri lah. Okay, field data collection. The next one will be, it is suggested the objective here for field data collection is to complete any kind of missing data. For example, if you've conducted desktop data collection, you find out that for that particular month, the electricity bill has been lost. The counting company suddenly maybe forgot to put it where it put the meter reading. So in order for you to make sure, you just check the last month punya reading from electricity bill, and then you compare to this month punya electricity bill, and then to make sure that this month punya electricity bill tu correct, you go to the site to make sure that the meter TNB tu shows exact amount yang, or maybe slight ada minus dah berapa hari ya. So there's a change, a few slight changes daripada nombor tu. But you make sure that the ballpark figure is being shown at the meter to show that okay betul, this reading that you got is actually is what the meter is showing and not being reka-reka lah by accounting punya department tu. So that are the type of validation that I meant by having, even though dah buat desktop collection, you still need to go to the site visit to validate that the data is correct. So, and also where the data could not be found during desktop data collection process. Kalau macam ada drawing tu hilang ke, nak tak nak kena pergi site lah, measure balik berapa square feet that area, for example. Okay, and then verifying the accuracy of the data, ni yang saya cakap tadi, which is betul ke meter tu tunjuk tu. That's one example I could give. And then understand closely the building operations to make sure that the data that you have collected show betul-betul indicate that process. Adalah mana nak tahu the data that you collected is for a few years back or maybe last year punya data. And back then, ada machine tu kat situ, but after maybe a good business for example, a good business punya operation, and the company deemed necessary to relocate the machine to another place, and suddenly the other building punya bangunan meter reading dia naik. So that's how you would be able to understand lah, which is to do field data collection to see betul ke mesin tu dipindahkan ataupun betul ke mesin tu is before this located at that building. So you make sure to be able to understand, maybe because that's more on verifying juga lah kalau saya bagi contoh macam tu, but more on understanding building operations ni basically cooling system or maybe production process to before this they conducted differently and now they conducted a bit more wasteful ke, so you have to understand why they want to do the wasteful method approach of production. Maybe because suddenly now the demand is too huge that they can't observe accurate efficient manufacturing process ke, mana tahu. So that's why you need to understand and do the site visit. And what does it mean by load profiling and load apportioning? So load profiling, basically you go down to the site, you look at the particular machine and you get the exact amount the machine punya load. Load tu maksudnya consumption lah. Electrical consumption for that specific machine. Sebab different machine uses different kind of load, amount of load ataupun macam contoh lah, your laptop, if you have a laptop and a desktop, your laptop will use a different amount of electrical energy consumption as compared to your PC yang besar tu, desktop tu. Compared to them, yang PC yang besar tu typically will use around 103 watt power. Power is P equals to IV, current kali voltage. So typically that kind of machine, computer desktop will use more than around 100 watt, whereby your laptop will only be using around 20 to 30 watt. Okay, saya tengok siapa laptop. If I'm not mistaken, ya betul. Okay, let's say lah 132, 320. But laptop will be quite less significant lah compared to your desktop. And then your handphone, your iPad, your tab or whatever will use much less amount of watt because you only plug it in maybe once a day, whereby your laptop you might be plug it in maybe the whole day, for example. So different kind of machine uses different kind of load. So what it meant by load profiling is you categorize or maybe you assign a specific kind of load, a specific kind of value to get a specific kind of value from the machinery that you're trying to measure. So again, load profiling is more on understanding which machine is using how many load or how many electrical energy consumption to know specifically which machine is using how much, which is and which machine is not using that much, so that you can address the problem more, what do you call that, more accurately. And then load apportioning is overall of the building. You can categorize, okay, the second floor is using more electrical energy because that's where the what you call that, HVAC system is being situated at. HVAC system is heating, ventilating, and air conditioning. So typically, anything that involves with cooling or heating, typically that will involve will require a lot of more energy lah than lighting, or maybe fan, or maybe because aircon memang paling mahal lah dalam rumah, aircon dengan fridge. So we will appropriate our load accordingly, according to the maybe the area, the building, the machine. It can be the same thing lah, load profiling and load portioning. And then to carry out field measurements which are required, field measurement nak measure lah any kind macam lampu pun kita boleh kira as field measurements. Any kind of measuring that you want to do, aerial dimension ke, the size of the room ke, is one of the field measurement that you could be doing lah during field data collection. So that's the objective that you want to observe. These are the objectives that is being proposed, that you want to make sure that the field data collection is comprehensive. So these are the suggestions by Turhajaya Tenaga. And then field data collection on the inspection of the energy and utilities supply system. The supply system can be from the TNB source or from the renewable energy source located in the customer punya ni, ataupun kalau customer tu memang ada dia orang ada own genset or generation electricity generation unit sendiri, macam apa nama, kalau siapa yang balik kampung dia ada ataupun rumah dia ada apa, bukan projector, apa nama tu yang orang tarik-tarik, lepas tu dia macam pasang malam tu kan, ada yang macam tepi dia buka lampu tu dia ada pasang macam motor tu. That's not genset, but apa nama, saya lupa dah. Saya lupa lah apa nama dia. Orang selalu panggil, saya lupa nama dia apa, tapi but that is
generator ke doktor?
Ya, generator, betul. Generator. So other side they have their own generator, of course a bigger version lah, kalau kilang ni lagi besar. So generator kilang typically not many kilang lah ada generator, but which those that do have it, then you can also measure it from that point lah, to know that the supply system is actually being, sebab generator pun ada dia punya level-level juga, maksudnya motor yang dipakai tu efficient ke tak. So some generator, those yang pasal malam pakai, typically will not be efficient lah. Typically they will use gasoline, but the power being produced may not be as efficient as a typical genset yang TNB pakai, because they consume lot more power to produce only lighting lampu dekat pasar malam, which is not good lah. Okay, sorry. So one of the example of utility area here, boiler house, macam tadi generator tadi, refrigeration system, and whatever energy supply being installed dekat that particular company site lah. So okay, and then That doesn't mean only on the parts of electrical supply, but also where it is being connected. Contoh, all the switch point dekat rumah awak, you can put a sensor on that particular switch point to measure how much is being used for that particular switch outlet. So the same thing goes here. Any kind of point that is being connected to a machine or to a load, we call a load machine, lampu, kipas, aircon, semua tu dipanggil load sebab dia consume electricity from that point. So any kind of load being connected to a point, you can actually measure that from that particular point. That means all the data logger apa semua tu tak perlu pun pasang dekat mesin tu sampai kena stop mesin tu punya operation. No, you can just tap dekat the main supply, not the main supply, sebab kalau the main supply it will not be accurate. But to measure a particular area punya consumption, you can tap at the power outlet tu. Kan any kind of machinery kalau nak pakai electricity kan kena cocok plug kabel dekat dinding tu kan. So might as well you tap dekat dinding tu. Lagi mudah. Tak perlu nak kacau tutup kejap, pasang data logger tu on balik. Whereby kalau machine tu, if you want to put the data logger in that machine, okay, one thing is it may not be accurate because certain part of the machine requires certain amount of energy. So if you attach the data logger at a wrong part of the machine, chances are you will not capture the accurate reading. And some more, if you attach the data logger on that machine itself, if the machine vibrates, if the machine operate at different high temperature boiler, for example, sangat-sangat tinggi dia punya panas itu, or maybe the condition is not very is very hazardous to the data logger, chances are your reading will also be wrong. So the smart way is to put your data logger more onto the data the terminal point what do you call it, the wall socket tu, lagi mudah. But that said, there are circumstances where one wall plug will be connected to at least three or more or two or more different machines. Ini typical lah. Kalau even rumah kita pun, kalau tengok wall socket rumah kita, boleh tengok satu wall socket tu will kita pakai extension, connectkan dalam 5-6 kipas tu barang, laptop, charger, what you call that, computer desktop kalau ada, or maybe fan, or maybe other different devices lah. So itu pun tak bagus juga. But at the very least, for that particular area, you have already measure lah what is the necessary equipment being connected. Again, the objective here may differ according to your situation. For example, your company, your client might want to just measure one particular area only. Then, yes, you need to measure each equipment being connected to the area. But for example, if your company or your client wants to measure the whole company punya organization punya area, or maybe electrical energy consumption, then you may not want to measure every single equipment being connected. You may just want to measure the whole area as a whole, as a summary. So that means you don't have to measure each electrical point punya socket. So most probably you'll just go to the main line, the main electricity punya main line yang connected to the building, and just tap it from there. It's much more easier. Why would you want to measure each terminal point or each machinery when the objective here for the company that has been given to you is more on the whole organization, so that they can identify, okay, this department, which department that they need to address to reduce their electricity bill. So that means once you find out that particular department, then only then will you go down to the machine. Then will be again, so it's much more convenient if you realize what the objective that you are trying to measure is. And then then you move on which area that you need to tap or the machinery that you need to tap. Okay. 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 Mana ni cakap ke? Never mind. Okay, so this is an example of a result that you get after you have understood the process and after you have done a rough ballpark measurement of a process, for example. In here, it shows the material and energy flows. So if you look at the process, if you look at the block diagram there, you can see that this is not this is not numbers and figures. This is just to understand what does the process consume and whether it is to understand the whole or overall process being apa ni lah, being the fuel needed, the exhaust being apa, produced, and also what is being produced. So in order for the machine to get the product, it needs fuel, electricity, steam, compressed air, and water. And then it also need raw materials. We can imagine this macam apa, lumber punya manufacturing lah. That means they may need to kayu balak tu masuk. Yang keluar tu maybe the cutted pieces of kayu balak tu. But in order for the machine to cut the kayu balak tu, it may need fuel ke, depends on the generator or the machinery punya fuel consumption, or just electricity, or if it's huge, typically people will use steam, compressed air or water to make it more, to cut to exact small sizes. Then chances are there will also be used water, especially to cut kalau nak mistaken metal. You will need water because if you cut steel using blade, saya terpaksa cakap slow ni sebab saya nak construct ayat saya in English, sorry, but I need to still to practice my English. So in order for steel to cut another steel, a blade of a steel to cut a steel, you need to have a water continuously flowing through the blade so that there's no heating up required for there's no heating of takut terbakar lah, sebab besi dengan besi potong. If you cut a metal with a metal, chances are there will be a friction being occurred there and causing heating up lah. Siapa yang pernah potong besi dengan besi tu tahulah, jadi lama-lama dia panas dua besi tu. So to avoid that and to make sure durability of the blade, typically people will either taruh air or grease or whatever lah to make sure that the temperature doesn't rise up. So that is also the material needed that needs to be considered for the process. So basically this whole diagram here, and also the exhaust lah, to make sure that we know what kind of wastage is being released to the environment, or so that you can also maybe use the exhaust air instead of just leave it to the open air. You can reduce it by reusing it as the compressed air required here, for example. So rather than open air, open loop, that means udara yang terbebas tu might as well kita sedut balik, pumpkan balik, so that tak perlu nak pump banyak kali. Even though may not be efficient as 100% air being compressed, being sprayed, chances are 60 or 80% being released to the environment. But even if you get that 20% of air that has been being used for that particular process, you can still save quite significantly over time, rather than leaving it just openly dispersed into the air. So that's the thing that kind of what you can propose to the client, which is to use pump lagi sekali to capture that kind of air balik, rather than sedut balik dari luar. Might as well pakai pump yang kurang power pun tak apa, tapi at least recycle balik yang air yang dah laju tadi tu. So this is an example of waktu you buat your field data collection tu, is the thing of a block diagram that you can promptly locate during the site visit. So this would help you to better understand the process, especially if you're not the person who operates the machinery for daily basis. So this would help you in the sense of auditing later on, to understand the data being consumed, whether betul ke, data macam logik ke, data being collected tu takutlah client tipu awak ke, somebody else tipu awak ke. So now you know machine tu pakai RON95 for example. Tapi tiba-tiba dalam dia punya data sebab dia RON95 pakai diesel for example. Tapi dalam data tu dia kata dia beli RON95 sebab murah. So dia tunjuk okay, energy consumption dia patutnya murah. Betul. So sebenarnya salah bukan salah dia orang. Tapi sebenarnya mesin tu pakai diesel. Whereby diesel is actually maybe slightly different prices lah. Of course kalau cakap pasal 20 liter dalam kereta tu memang tak nampak beza. Tapi if you're buying for machinery, typically in terms of gallon. So diesel kalau beza 20 sen dengan nanti RON 95 pun, kalau 20 sen tu beli in gallons is quite significant boleh beribu juga. So tipulah kalau dia kata dia pakai diesel tapi sebenarnya RON 95 or maybe RON 97 ke apa, I don't know. So this will help you understand to understand, because you have to understand now the process of a company, chances are may not be only one typical process. If especially if the organization if the company wants you to measure the whole organization punya energy consumption, there will be at least 20 to 30 process that you might want to understand. So having this block diagram, which is called material and energy flow, will help you to generalize the whole process, every single process that are in the organization, so that you won't be cheated, or maybe you want to make more sense of the data that you have just collected. Okay, so penting material and energy flows ni. So make sure every time, if let's say lah, you become or you set up an energy management program, which is now saya dapat tahu just semalam, it seems that Menteri Kesihatan dan Alam Sekitar and Tengku Zafrul, our finance minister, had just met up and come up with a proposal and studies to implement carbon tax. So when people hear carbon tax ni, diorang ingatkan yang exhaust kereta tu, motor exhaust kereta, but no. It's more on energy management. So moving forward, I think it's a good thing because now I think last time when there's a meeting dekat yang Joe Biden tidur tu, yang diorang share gambar Joe Biden tidur tu, Malaysia kena marah sebab our energy compliance isn't up to par with our target. So they have been kicked lah in the butt to continue with the energy management. So that means there is an opportunity for you in the future to set up energy management company to advise client. This is how you can reduce your carbon footprint to save yourself from that tax. When will the carbon tax being implemented? I don't know. I'm not in the politics. I'm not involved with any kind of the committee that discusses on the tax. I don't know much about tax even. So I would think if the target they put there was 2030 or 2044, I can't recall. But even if it's true, chances are in 2 or 3 years' time, that carbon tax will be implemented. So that means now you have not only you'll have regulation 16 to help you to approach a company to propose your solution, now you have that carbon tax incentive. If they produce, what you have to understand with carbon tax is that the tax will be heavily penalize those who exhaust carbon emission. Carbon emission meaning the amount of energy they use and the amount of carbon being released to the environment will have to be the exhaust must be minimal. But if they found it to be huge, that means there's a lot of wastage being happening in the car factory, and then the tax will be quite significant, will be levied significantly to those companies. So most companies won't know what to do with that. I mean, to incorporate any kind of technology, they have to hire other people. So this is where you can come in as a energy management company. Of course, it won't be easy to engage your client to come up with proposal. Typically, they won't even let you in the front door. But once that tax being implemented, chances are you will be called if you set up the company lah. So I wouldn't say that will be black and white. There will be a gray area, but that's one of the opportunities for energy manager to come in and set up their own consultancy lah, which can bring you money, of course, but also a way for you to practice your electrical energy management. I'm quite interested to see where the carbon tax is, where and when the carbon tax is being implemented. So anyhow, if you concern yourself, apalah aku belajar ni, bukannya aku nak pakai pun. Trust me, there will be a chance, who knows, in the future that you might be the energy manager one day. In fact, I think Petronas pun ada their own department of energy management, but how effective they are, I'm unsure lah. So you have to double check with them. Okay, so back to the slide. So this is the block diagram that's going to help you to better understand the process that you're trying to measure, so that you know where to tap your sensor, data logger, or whatever measurement that you want to measure. You will know. So like this, for example, the one that will be given here, what you want to measure is this part, not the raw material, not the product output. Of course, product output ni, of course you might want it jugalah. Sorry, saya salah ni. If you want to measure the efficiency of the process, what you want to measure is this one. This is the first one. And this one can be optional. You can either measure this one or you can measure this one. It's up to you which is the more accessible and safe. If it's safer for you to measure the condensation rate, the exhaust air, the product waste, then I advise you to measure this one. But if it's not safe, radioactive or whatever, or maybe the temperature is too high, you might want to measure indirectly the product output. Not so much on the raw material, but of course raw material could also be measured if it's required, but that is the hierarchy that, for me, logical for you to pursue. Okay, one and either the two here, and then lastly is the raw material being inserted, so that you know whether the process is actually efficient or not. Okay. So that's how I would read data, material and energy flows. Okay, and then we look into, once you have collected all the data, you need to conduct your data analysis and also present the finding so that the client understand what just been collected and what the data is being shown. Sorry, so data analysis and finding, basically what you want to do is to cross-check the load demand data. Load ni again, bila saya cakap load ni bukan siapa yang angkat besi tu dia ingat angkat benda berat. Bukan. Load ni is any kind of machinery, equipment, even lighting pun, even fan pun is actually a load for electrical engineer. Sebab dia akan consume any kind of machinery, equipment or whatever thing that uses electricity for it to operate. Even your mobile phone pun boleh dikira as a load, provided you plug it in to the electricity line nak charge basically. So that is what is meant by load. And load demand data is basically the technical specification of the machine how much electricity it draws, how much it's being used, the rate, the tolerances, because you don't want it to give it, let's say it only operates at maximum 2.4 amp to charge your phone, but you supply 10 watt to the phone, and boleh meletup phone tu. So make sure nak pakai wall socket tu jangan pakai yang aircon punya wall socket tu, awak cocok situ masuk ke phone awak, memang meletup sebab aircon punya current tinggi Kalau perasan dia punya plug pun lain, bulat. Our wall socket, kalau kat Malaysia ni, typically will have that three face, apa nama, ada satu atas, dua bawah tu kan. But for aircon dia lain, dia bulat. Yang dia punya, dia sama, tiga, tapi bulat tengah-tengah. Okay, so tak apa. Okay, and then energy management finding. So this is the thing that you need to produce by the time you have that data. Once you have analyzed it, which is the energy matrix, the one that I've shown to you earlier, this chapter. And then any kind of technical finding, which is the load apportioning, air ratio, fuel consumption, whatever, semua masuk dalam tu. And then what kind of energy conservation measures? Okay, be mindful of this. Apa nama? Nama pendek ni. Kalau bahasa Inggeris saya lupa, dah cari-cari. Dalam otak saya tak jumpa pula. Tak tahu. Tapi energy conservation measures sebab from here moving on, dia akan banyak short form. And takut nanti kan ramai yang terlepas pandang. So ECM is energy conservation measures. ESM, energy saving measures, lebih kurang sama je sebenarnya, tapi itulah dia guna interchangeably, so takut nanti confuse. So ECM is energy conservation measures. Any kind of financial plan that you want to implement to make sure that energy conservation measures proposed, it could be realized by the client. And what kind of implementation plan that you had in store for your client. Maybe kita start dengan low cost dulu ke, or terus ke high cost dulu ke, depend on the funding by the company. Okay. Okay, this apa yang tadi cakap pasal load apportioning, ni dah dia. It's, if you look at the pie chart ni pun dah senang nampak dah. Which are the equipment that uses the most electricity? Chiller plant. Like I said, any kind of equipment that may want to interfere or adjust the temperature, that plays around with temperature, will consume electricity significantly. So as you can see here, chiller plant, chiller ni yang HVAC yang air condition, kalau kita main kalau kita pergi bangunan contoh KLCC, if you look at any kind of mall, you'll notice that semua kedai tu tak ada, macam rumah kita kan ada yang indoor unit tu, yang aircon dalam rumah bilik tu. Diorang tak ada, diorang totally daripada atas, daripada bumbung tu, they have that distributor and then they terus pergi. So that is what we call as distributed centralized air conditioning. That means they only have one chiller, one HVAC system to supply to the whole building. So typically, because it supplies to the whole building, chances are the machine is very big lah. So chiller plant tu big lah. Selalunya kalau for those who typically see yang atas bumbung tu, yang ada mesin besar yang macam bising tu, tu chiller plant tu. Sorry, banyak pula angin pagi-pagi. So given that its size and its operational, chiller plant typically will consume the most electricity bill, electrical energy consumption for the whole building, compared to UPS, compared to pump, compared to any kind of even lighting. Okay, AHU and FCU ni is more on toward fan. Air, apa AHU? But because I'm not a civil engineer, so I'm not familiar with all these items. And of course, I'm instrument engineer, but I'm more on one or two machinery, not so much as the whole machinery. So I might need to recall. Hold on here. Let me get back to you in a bit. Give me a second. Fan coil unit and air handling unit. Fan coil unit ni for those building that typically wouldn't use air conditioning. So, or maybe they use air conditioning, but FCU is part of that air condition, because in order for you to use air condition, you need to have a fan blowing cool air into a strips of copper cable where the chemical comes in, change their conductivity with hot air. So you still need to have a fan unit there. So that is part of the HVAC system. And air handling unit is because when the air comes in to try to condensate with the cool air, so you need to have some sort of mechanism or the chemical to flow to help fasten the process of transitioning between hot air and cool air, so that the room can be being cool much faster. So even AHU and FCU is part of an air conditioning unit. The chiller plant themselves is chiller plant ni yang bagi cool air, yang translate all the cool air and hot air, whereby AHU and FCU is the equipment that help the process of transition between cool air and condensation between hot air and cool air. So there are, even though it falls under the same what you call that, HVAC system, but the power consumption between these two is actually totally different and totally significant, which is chiller plant 48, AHU and FCU is 13.5, which is almost as similar as the whole building punya lighting system. So HVAC system memang makan portion electricity paling banyak lah in any kind of a building. So that is how you identify and load apportioning. Apportioning kena sebut. Portioning. So if you, as an energy manager, if you want to propose to a client how to reduce their electricity, then most probably you will need to address chiller plant dengan AHU FCU lah, rather than the other parts, which is UPS only 2.4%. UPS ni uninterruptible power system lah. That means if there's any shortage for that mall lah, for example, KLCC, then they will kick in to make sure that lampu semua masih menyala, ada udara bergerak at least, even tak sejuk. So at least for maybe 1 or 2 hours while we wait for the main system to be repaired, bolehlah pakai UPS ni. Pump, any kind of ventilation, any kind of lighting pun masih lagi kalah dengan HVAC system. Even though lighting the whole building pakailah terang gila building tu, but anything yang involved with the temperature will significantly consume electricity bill that much lah compared to any kind of other equipment. So that means you as an energy manager might want to focus more on chiller plant, improving the chiller plant. Either you change it to, if you have the what you call that, the funding, propose to the client to choose a much better or a more efficient chiller plant, or maybe a more efficient AHU and FCU unit. Okay, because that would significantly improve the electricity bill. 48.4%. So that's the function of load apportioning, so that you know which area that you might want to target, or which equipment that you might want to target to give a better result to the client. Okay, and then this is another sample of technical finding where you identify the losses of a process or equipment. So in this example, it shows to you a steam boiler system. I keep on saying steam boiler or boiler to you, but what a boiler does is basically to give electricity to, macam generator lah pasar malam tu. Instead of pasar malam generator tu, boiler dia pakai. Ini typically you can found this in TNB punya pencawang lah. Boiler besar ni. Basically dia masukkan fuel, air ke apa ke, then dia keluar electricity sini kan, I'm not sure lah which one. Tapi adalah electricity keluar. Saya sendiri pun tak pernah interface dengan boiler because I haven't worked with TNB. But in general, boiler is being used to produce electricity, right? So based on this technical finding, basically you want to find out what are the kind of losses occurred for that boiler process. So for this example, you have flue gas loss, gas lah, basically gas losses. Of course, bila awak bakar something akan ada gas lah keluar. Physics for those who I'm not sure be apa business punya ni ada physics tak, tapi for engineering physics ni part 1 kita belajar. Dia punya rule basically simple. Physics in dunia kita ni, in earth ni, physics dia simple. Any kind of energy that you consume will also be the same amount of energy that being produced. Cuma bentuk dia can be different. For example, kalau awak makan 5 suap nasi, 5 suap nasi punya kerja ataupun load lah yang akan terhasil. Kalau awak berjalan, kalau 5 suap nasi tu pakai habis, then habislah. Tenaga berjalan, tak ada membazir. Tapi if 5 suap nasi tu awak duduk, macam saya ni duduk je sedentary lifestyle, depan komputer aja, then chances are that 5 suap nasi will be either dalam bentuk nafas, dalam bentuk kentut, dalam bentuk apa air najis ke apa ke, itulah dia. Ataupun dia jadi lemak. Badan kita pun store that kind of thing. So, kalau fizik kata 5 suap nasi yang masuk, 5 suap nasi jugalah amount of energy yang akan terhasil. Kalau awak tak pakai untuk berjalan, then most probably jadi tahi lah. Jadi tahi ke, jadi lemak ke, jadi whatever kentut ke apa ke. Tapi dia akan equal to 5 suap nasi juga. Itu fizik kata, which is physics, the same physics that people use to send people to the moon, to send rocket and then patah balik masuk bumi. The same kind of physics that's being used. So, kalau yang skeptical kata sains tipu lah apalah, try lah pergi keluar create a rocket and try to see whether that physics teori tu betul ke tak. So, same here, goes here lah. So, you want to find out the amount of input air ke, fuel ke, there should be the same amount of energy being used. Sorry, let's say for example, air pakai 5, fuel pakai 5. What kind of unit ni jangan fikir dulu, just fikir 5 ketul atom. 5 atom of air, 5 atom of fuel being used as input to the process, the boiler process. You should expect, kalau ideal cases, that means zero losses, the 10 amounts of energy, kalau sebab boiler ni dia menghasilkan electricity, so you should expect 10 amount of electricity atoms being produced by the 5 air, 5 fuel. So ideally 10 lah, tapi in real practice, there will be maybe a quarter in convection, or maybe a 0.0000001 convection. Or maybe, another quarter from blow down loss, leakage loss, and condensate loss. Or maybe half loss dekat gas loss as exhaust, which is logical. So, kalau awak measure dekat sini, instead of 10, awak dapat maybe only 2 je. Daripada 5 and 5 ni, awak dapat 2 atom je electricity being produced. That shows this process memang tak bagus lah, this boiler. So, what you can propose to the client, either you reduce the losses by convection apa semua ni, by maksudnya convection ni temperature lah. So, control lah temperature ni dalam ruang area ni. Either pakai kipas helikopter macam dekat masjid-masjid tu ke, or just buat natural cooling. Maksudnya jangan tutup semua ni dalam tempat berkurung. Apa nama? Buka lah kipas-kipas dalam tingkap-tingkap dia semua tu, so that udara mengalir. So convection loss tu kurang. Or kalau ada leakage losses ni, maksudnya kena repair lah, buat maintenance lah. Solder balik mana yang terbuka, tutup semua tu. Yang dah rosak-rosak tu, solder balik karat-karat tu. Condensate loss, sama lah macam convection loss. Blow down loss, maybe ada machine punya efficiency lah basically that you need to maintain, so sama lah macam yang saya cakap tadi tu, yang kena repair tu. So identifying losses ni, which is ni lah saya cakap 5 masuk, patutnya 10 keluar, tapi awak dapat 2 je electricity daripada yang terhasil. So that means this process isn't efficient. So then you can come out to the client, okay, rather than any kind of proposal that I would recommend pun, I think the best way is for you to handle losses ni better. Buka tingkap, repair welding balik yang karat tu, buat maintenance dalam boiler tu, make sure all the
scrum apa yang kotoran-kotoran tu dikeluarkan. Then the machine should operate much better and reduce the electricity being used lah for that particular machine. So that's the one of the thing that you could find during your technical visit, your site visit, which is identifying losses occurring for that particular equipment or even the whole area. Okay. I think we could take a break for maybe 5 minutes before I continue with the rest of the slide. So now my watch is at 9:08, 9:10 lah. So we will continue at 9:15. Take a break for 5 minutes. Thank you. Okay, let's continue. The sooner we continue, the sooner we finish the section, the chapter. Boleh continue? It's 9:15. You should turn on your camera, yeah? Okay, some of you have already turned on your camera, but most of you haven't still. So we'll wait for a bit in case they are not in front of their PC. I just want to make sure that everyone is in front of their PC before I start. Okay, so inshallah most of you are already in front of the PC, so we'll continue. So there are three types of energy savings that you can propose to the client. That being no cost, low cost, and high cost. Typically, high cost wouldn't be appreciated by the client. If you highlight that, okay, I want to propose this amount, $500,000 amount of energy saving measures that you could do. Tak payah cakap, tak payah habiskan tu, confirm klien kata, okay tak apalah, baliklah, kami tak nak dengar. So, jangan sekali-kali start your proposal with high cost. That is the smarter way lah. So, what you should do is, once you have come up with a proposal and meet the client, is to propose the no cost first. Depending kalau klien memang cakap, okay saya memang semangat sangat lah ni nak elak tax carbon ni, so saya nak terus pakai renewable energy. Okay, fine. Tapi still start with no cost dulu. Sebab that shows you as a service provider indicate to your client that I'm thinking of you first, not so much as me, because I know if you want to perform the high cost implementation, chances are, of course, I'll be getting paid quite significantly lah. But no, I want you to achieve cost saving first before I get my money. So that's how you build a rapport with your client. So always start with no cost first, because even if you ask any AMAS ke, green technology ke, they will always ask you to start with no cost first, because this means that no cost typically will be something that is so simple that typically would contribute no cost to the company. It's just a matter of either user awareness, which is just you letting your technician know that, okay, when you go out of the room, turn off the lamp. Macam keluar makan tengah hari, sejam, 2 jam kadang-kadang, tak tahulah kan, sejam for example, tutup lampu, tutup aircon sekejap. Dah masuk buka dah balik. Lepas tu dalam 5 minit mesti sejuk balik. Tak payahlah nak buka dia kan. Tak ada orang dalam office. So user awareness, as simple as turning off the switch actually could save significantly your electricity bill for the whole month. Or the whole year, in fact. And maybe just reschedule load or usage. So instead of operating the machinery heavily during peak hours from 8 to 5 a.m., 5 p.m., try maybe buat scheduling so that orang technician yang masuk pagi tu tukar masuk petang ke, and then operate that machine heavily after 5 p.m. Sebab particularly at that particular moment, load semua dah kurang, so TNB boleh supply electricity banyak dekat awak, so dia tak perlu nak fikir orang lain. So tak apalah, dia kata okay lah, kita cincai lah, habiskan lah electricity yang kami generate banyak ni untuk hari ni. So tak perlu pakai ni pun, gaji masih lagi bayar gaji pekerja yang sama. You still paying the same amount of salary to the person, except for now that person tak perlu masuk time office hour, masuk after office hour, graveyard shift lah. Basically tak ramai yang nak, but selalunya untuk single person yang tak kahwin lagi tak ada isu pun. So tak ada additional cost. It's just rescheduling or creating shift. Maybe technician tu mula bising lah, tapi dah owner tu bos dia. Nak cakap apa, terima je lah kan. So always start with the no cost first, because chances are no cost is much simpler, which can be done almost immediately. Tak perlu nak tunggu. Macam high cost ni, typically what you need to do, if the company doesn't have the funding, tak they have their cash, even if they have their cash pun, you still have to do product study. Maksudnya you want to buy the best kind of the best suited technology for that particular money that they have. So tak boleh lah nak propose to them ladang solar 50 hektar padahal dia punya duit hanyalah 20,000 ke 200,000 saja, tak cukup lah kan. So if possible, try to no cost, because nak implement itu almost immediately. And for no cost. And then low cost pun boleh juga, depending on the client. Again, still need capital, but not so much. Most probably less than 100,000. For them to just install or maybe replace LED, instead of pakai panel floor yang panjang tu, tukar kepada LED punya lampu. Cooling system improvement, maksudnya tukar aircon yang indoor unit tu jadi yang aircon tu jadi ada inverter punya air condition. So pun okey juga, still bawah 100,000 kalau tukar the whole building. For example, saya tak sure how big the building is. And then housekeeping, maksudnya bukan kemas rumah. Make sure aircon tu, filter dia tu bersihkanlah, so that it becomes habuk-habuk semua keluarkan, so that efficient dia punya, basically service lah, service all your equipment. Insulation, so that haba tak terlepas keluar. Ni negara sejuk lah kot, kita insulation nanti ada. Actually our building pun ada insulation, but not so much on about keeping the heat in. It's more about keeping the heat out. So kita panas lah, negara panas. So those are the low cost. I mean, you still need capital, but not so much, or not too big lah compared to high cost. So high cost ni typically, when you're talking about high cost, you typically change the technology for any kind of usage. Machinery tu pakai yang canggih ke apa ke, aircon tu pakai yang instead of power up by the wall socket, pakai solar ke. So significant punya changes lah being done to the technology being used currently. So for low cost and no cost, typically it will be done via internal initiatives, SEMs, SEM, I forgot apa nama terms ni. Internal lah, basically self-evaluation measures. So self-evaluation punya management lah. So that means you tak perlu hire orang luar. Whereby kalau high cost ni, it can be internal if the funding is from the company themselves, the owner themselves, but can also be with ESCO. That means the company may not have the money, but you can construct a structure where the energy service company, ni ESCO ni energy service company, saya mahu tulis, tapi energy service company basically what they did is they buy it for you under the pretext of loan. And for a period of time, maybe 10 to 20 years, they'll collect the energy saving, which I will discuss a bit later on after this. They'll collect their untung tu in 10 to 20 years. And after that, all that solar panel ke, apa ke, semua falls under you. So any kind of energy savings from then on is yours. It's the company's, not the ESCO lagi dah. So dia ada period of time lah. Dia akan dulukan duit lah basically. So ESCO ni, what you can summarize, is a company that buy the energy equipment machine for you, and for a period of time they'll collect the energy saving from you. That means you don't have to pay them. They'll collect the electricity bill that you paid previously, the amount yang dia dapat savekan tu, they'll collect it as their fees, and after 10 years then they'll back off. So there's no obligation except that now you have to maintain yourself lah, the equipment, and everything is under you. So any kind of energy saving falls under you. But you have to remember, typically this electricity bill will be in terms of 100,000. So it is viable actually to engage ESCO so that they install solar panel in your facilities, for example. Instead of now previously you're paying 100,000 per month, for example. Now maybe you're paying actually 60,000. So the rest of 40,000 actually belongs to the ESCO until 10 years, and then only then after then you'll be able to reduce your electricity bill to 60,000. But again, the solar panel is under yours to maintain. Right? Okay, so this is the backbone of your energy audit reporting that you need to present to your client, to submit to your client. Basically, these 10 items, 11 items needs to be in your report. So later on, when you do your mini project, I expect to see all of this lah. These all should be included in your mini project report. So you have to have the executive summary, introduction, scope of work. So this one, actually you can just, I think there's a sample of energy audit reporting that could be found in the internet. If I'm not mistaken, yeah, because even my past students also have been able to do this. So yeah, there should be an example. I think in the last chapter, yeah, we will share with you the sample of energy audit and also the report proposal. So all of these elements needs to be explained or elaborated in your final report. Basically, this is the skeleton you need to use on all the other parts here. So where's the proposal? Is in here, energy saving measures and recommendation. Where is the profile of the company that you need to let your client know where they are right now, which is in this part here, 4 and also 5, I think. Yeah, 4 and 5. And the other part is more on supporting documents to show that this is how you do your audit and this is the result of it, and what kind of steps that needs to be done after this, which is this part. Okay, so you can just read it there, but basically the backbone is this lah, this 11 item. Make sure you have it in your energy audit report. Okay, so how to review energy audit? Why do you need to review? Of course, you need to explain to the client what is being accumulated here. So to review it, first you have to ensure the accuracy of the operating hours, because if there are energy consumption after operating hours, chances are there's leakage somewhere. Maksudnya mesin dah tutup tapi minyak masuk lagi. So that means ada leaking lah, kena welding, kena apa patut lah, kena service ke apa yang patut. So, and then ensure accuracy of equipment operating hours, the same thing. Kalau facility dengan equipment tu almost the same thing lah. Maksudnya kalau ada something wrong tu, tak tally tu, that means ada something, kena buat maintenance lah kot. And then accuracy and energy demand rates used in the energy audit. Make sure rates, the energy that being used and the demand of the energy tolerate with each other, because if not, then that means the losses yang saya mention tadi is quite significant for the service. Appropriate project recommendation for the facility. When you mention project recommendation, SEM lah, ESM lah, energy saving measures, is ESM and ECM. So you have to make sure that ECM or ESM that you're trying to propose must not be too complex, depending on the company level. The equipment that you want to change, let's say for example, you want to propose to use air condition that has inverter technology. Make sure it is compatible. Sebab kalau klien tu pakai centralized air conditioning system, kat mana pula awak nak cucuk awak punya indoor unit yang ada air inverter teknologi tu? Tak boleh lah. So kena make sure it's compatible with the client punya side. Equipment reliability, of course, this is based on track record. If possible, come up with a proposal that use equipment that have the best track record so that client don't have to keep on calling you every single projek dah 50 tahun, dah 20 tahun pun dia still contact you lagi. Awak yang beli. Awak tak nak kan? So make sure it's reliable, the brand is reliable, the equipment is reliable, not just cheap. And then operational cost to implement the ESM and ECM that you want to propose to the client. Janganlah mahal sangat. Beli equipment tu 5,000 je, tapi nak pasang je 10,000. Which is can be ni sebab how canggih the equipment is may require specialist lah. Okay, and then accuracy of existing equipment identification in the energy audit. Okay, so what does this mean? This text here means is that some equipment dia punya interfacing is really bad because it was 10 or 20 years punya machinery. So you don't have any place else to tap. So the identification of the energy being measured is actually indirect. So that data may not be accurate. So kena, kalau boleh, kalau tak ada data lain tak nak pakai lah. But if there are other data that can reflect the process being consumed or being processed in that particular machinery, pakai that data. But if not, tak nak, and then buang data yang you have measured tu. So but if not, tak ada data lain, tak nak kena pakai lah. But you have to mark there, this data is with a tolerance of 5 to 10% to your client nanti lah. Sebab client can argue, biasalah client will argue your data that benefit them, so that dia tak perlu beli equipment mahal ke apa ke, tapi you know that even though that data may not be accurate, but there is some relationship that you show based on mathematical ke apa ke, statistic ke, to show that even though this is not direct measurement, but there is correlation with the process, for example. So accuracy is also important juga, nak make sure data you betul, and of course to prove your point to your client that this data and this finding is actually true. Okay, and also make sure to check overestimating the energy savings. This one nanti for your own good lah. If you say, okay, client saya target 50% by end of 5 years ni, insyaAllah energy boleh save. Tapi by the end of 5 years dapat save 5% je, bukan 50. You promise 50. Saya dah spend macam-macam dapat 5%, rugi lah saya. So make sure jangan overestimate. Make sure how to do this is, of course, you have to rely on experience of other people lah, especially those energy manager that have already implement the kind of ECM and ESM that you're trying to propose to the client. So based on their projection, how much should you expect? So don't suka-suka tambah-tambah, dapat nanti kan akan bite you back later on, especially if you are working in that company. Use of appropriate simulation models and assumptions. Ini again so that you don't overestimate your savings. Make sure your model that you use to project 10 years punya saving energy is correct. So itulah, janganlah awak guna quadratic, awak guna linear, tapi sebenarnya yang awak calculate tu is quadratic, tapi sebab nak tunjuk cantik awak tunjuk linear. Salah lah calculation awak. It will bite you in the back later on. And then project cost estimates, or including all the equipment, installation and whatnot, so that the client would be able to get a clear picture on how much they need to spend. Not just ringgit and cents, but also capital, human capital, to to make sure people ada, a technician ada waktu tengah pasang tu ke, so dia tak rosak your equipment, for example. Okay, and then what kind of output that you should get and present to the client other than the report, basically is the energy use and consumption, existing energy use and consumption, the current energy source, the past and present energy use and consumption analysis, whether it is being, basically energy matrix tu lah, whether they are using their energy efficiently. And then areas of significant energy use, SEU. This is to identify to the client that, okay, this macam yang load apportioning tadi tu. It was shown that let's say for example, from load apportioning, that the chiller consumes the most electrical energy. So if you recall, chiller plant is 48.4%. So that means if you that means you can tell to your client, there's no point of your client uh, bising dekat department law or department accounting, because even if they did their electrical energy to 100% sekalipun, if their chiller is not being serviced, it's not being changed or whatever else, chances are electricity bill tak akan berubah lah. So if you want to impact your electricity bill majorly, address that particular area, which is chiller punya area lah. Either you allow air cooling juga berlaku dalam tu, or maybe you introduce another set of chiller ke, for example, yang boleh more efficient ke. So it is important for you to identify which area yang pakai electrical energy ni significantly. So that's the kind of output yang client you would expect. And then prioritize recorded opportunities for improving energy efficiencies. Ni memang kita lah as a energy manager. If you recall, the field auditing process, memang after you measure the key parameters that you want to measure, they ask you to find any kind of energy potential that you could save, energy saving measures that could be saved, record the opportunities, so that client knows that, okay, the next step after maybe doing the no cost, maybe they can come back to you as a returning customer to help them to implement the low cost plug, for example. Of course, with a fee lah to you. So this is actually for your own good lah, to keep on getting businesses coming your way if you are an energy management consultancy companies lah. But if you're just working there, kalau tak nak buat kerja, tapi still kenalah propose, sebab manalah tahu dapat save electricity banyak, naik gaji you. Okay, and then energy review shall be updated at defined intervals. Of course, energy review should be done periodically to make sure that all the suggestions, all the findings, all the improvement have been recorded and have been continuously updated to show that, okay, as year goes by, all the measures that you have proposed is actually relevant to the electricity bill being saved, the energy management being used. And then perform continuous energy baseline, also the performance indicators, energy performance indicators, to make sure that the energy management progresses continuously improving year after year. Okay, this is also important to get your 3-star if your company agrees with your proposal. Okay, so to kickstart the implementation, okay, this is at the stage of implementation after you present to your boss and they agree. So these are the things that you could do to as a guideline for you to start the implementation. Which is, the first step is to analyze and evaluate the proposed ECM, because chances are most probably after 1 or 2 years you may have forgotten the ECM or the energy control measures or energy conservation measures that you have proposed to the client. So you may want to revisit and reanalyze whether it's still applicable or not, because changes in operation, changes in human capital. Let's say technician dulu kerja kita now dah berhenti, yang technician baru tak pandai nak pakai equipment baru. Lepas tu tiba-tiba orang nak propose pula another equipment untuk ECM measures, memang jam lah. So kena make sure re-evaluate lah your ECM that you propose last 2 years, last 3 years, still applicable today. And then after you deem that ECM to still applicable, what you can do in the next step is to present the EMC Energy Management Committee, to present to the Energy Management Committee of the ECM or DSM that you have deemed masih lagi boleh, to get their approval to be implemented. And then once you get their approval, step 3, you need to immediately implement the first part, which is no on low cost, because that is the most orang kata immediately punya effect. So kalau nak tunggu yang high cost, chances are maybe 3, 4 or even 1 whole year waiting for the equipment to arrive to your facility. Dah lah nak kena beli, nak kena sort out, and then nak kena tunggu delivery lagi, nak pasang lagi, nak make sure dia jalan lagi. So it can be a long time before you can wait high cost punya energy efficiency. So even though klien kata dia nak high cost terus, dia dah ada duit, try start with the no and low cost first, because that is the most basic thing that you could impact your electricity bill quite significantly while waiting for the high cost measurement equipment to be delivered, to be pasang. And then also step 4, consider EPC for high cost investment. Energy power company, energy provider contract. I think okay, ni lah masalah slide ni, dia bagi term-term ni dia tak explain. So I think for high cost investment, what it meant here is the contract that you would sign with the energy service ESCO lah, energy service company tu. Basically to install, let's say for example, solar panel in your facility. The reason why I keep on saying solar panel, because that is the most feasible dekat Malaysia ni. Tak boleh pasang wind turbine, kita tak boleh pasang hydroelectric sebab sungai pun tak yang besar ada, tapi tak adalah dekat office kita kan. Chances are Sungai Kelang tu awak nak pakai hydroelectric memang tipu sangat lah. Mengalir pun nampak macam tak mengalir je. So EPC typically you are talking about solar panel lah. And then for high cost, make sure seboleh-bolehnya propose to them to use EPC, which is energy provider company punya contract lah. And then step 5, if they agree, and also if, whether or not they agree or not with step 4, you can still perform measurement and validation for pre and post retrofitting project. Basically, if let's say they agree or not agree with the high cost investment contract, they, let's say lah, they beli equipment, any kind of equipment to improve. Sorry. Basically you retrofit the equipment into your existing company, existing equipment. So make sure you do the validation, make sure betul, dia pasang tu betul. So apa ni lah, energy saving tu make sure berlaku lah in that particular machinery. And then monitor energy performance indicator and reporting to energy management committee. So make sure after you have done the installation, make sure it runs, and then report the monitored punya variable tu kepada energy management committee to make sure that okay, saya dah buat and ni result dia, to show the what you call that, the work that you have done lah, it's actually betul, have achieved the target that you set. And then once they and then lastly, the management will, the committee lah, top management and the top committee will review the system and energy saving achievement to whatever end that they want to pursue. Nak 3-star, nak 3-star gold star by AMAS ke, ataupun just nak simply stop dekat having saving in the electricity bill ke, it's up to them lah. But it's up to them to do whatever that they want to do with the saving achievement that you have achieved. But again, you still have to submit to them for their review to show that your work is done. Not to say done lah, I mean year after year you still need to continuously find out and measure the energy measures that you have proposed. But of course, it's for them to review whether to help you maybe in the future to get other businesses with them in terms of energy management. Okay, so these are a sample of report by energy saving company that has been recorded in the slide here. I think this is from practical punya Dr. Nabil punya experience. So tak nampak the detail, but you can see the client received 5-star with energy. Kalau 5-star, that means BEI dia less than 100 lah. So I think this is hospital, I think. Is it hospital? I can't see it, but this building has been able to get from 2 stars, which is between 160 to 250 DEI, they managed to receive 5 star, which is under 100 by, which is 39% in 39% energy saving being able to be achieved lah by that particular building. So we are talking about building, not just a company. This is government building, I think, hospital. So after adjustment, which is 29%, actual energy being realized. Potential actual energy saving have been realized by this report. So whether this is actual data or not, I'm unable to show, to confirm, because this is most probably by Dr. Nabil. So I guess he put here is most probably based on his own case studies lah. So he's the practitioner. I'm just the lecturer who has the energy management license but haven't been able to practice because again, Terengganu, you don't have that much businesses here. But I guess from his part, this is what has been recorded. Right? So this is a sample of proposed ECM by ESCO. So basically this proposal is submitted by the energy supply company, service company. So they conducted the audit in that building, and this is what the proposal of ECM, which is, as you can see here, this section involves low cost. This one, I'm not sure, sustainable energy management setup. This is more on, is this high cost? Hold on, energy saving, 5 payback period investment. So this will be still low cost. So this is high cost. This is no cost. This is why I'm saying low cost. No cost because this is almost less than what, 100,000, and this is significantly higher. But sorry, RM this is high cost. This is high cost. This is low cost. This is no cost. But also actually low cost lah. I put that low cost because it still involves almost 10,000 or 15,000 overall. This is 50,000. This is medium cost. That means. So there's no high cost here lah. Sorry, this is also low cost. So there's no high cost over here. That means the client don't want to have to install solar panel or renewable energy lah in their building. So this is an example. So that means jarang sebenarnya nak propose high cost dekat client unless memang if that particular building memang orang kaya ke. Macam for example, for those who have come across the building of YTL, I think. YTL punya rumah tu. If you recall, dia letak bangunan dekat Bukit Tungku ke mana, rumah dia yang cantik gila tu. That one, yeah. That one will high cost because dia pun ada buat natural heating, natural cooling. That means udara masuk pun if I'm not mistaken, the design itself is allows for natural cooling, natural lighting. Yalah, YTL kan memang orang kaya billionaire, so tak ada masalah lah. Dia nak buat tu, dia ada duit sendiri up to themselves lah. But that one is one of the rare cases of proposal diberi memang taruh dalam tu high cost. Tapi typically business owners memang nak paling ni pun tinggi pun low cost lah. Which is tukar lampu. Tukar lampu tu paling dia orang suka lah. Instead of pakai conventional pendor floor lampu, the ECM being introduced would be to change it to the one yang ada lampu bulb yang energy saving efficiency tu. Not only much more brighter, but also energy saving. Electricity consume dia pun lagi kurang daripada lampu yang top down yang biasa office pakai tu. Okay, and then this is a sample of reporting format to Energy Management Committee. Tadi tu is ECM and also report by ESCO to the top management. Now it's to the energy management committee of that organization. So as you can see there, there's the okay. This one will be exploring it in chapter 4, chapter 3. I think chapter 4 will be exploring this EEI, and then this is what we call as baseline EEI, and this is baseline. So these are the things that you will need to have in your mini project. EEI baseline ni memang typical. Every single year you need to update this. So if your proposal, let's say for example, you propose after maybe 2 years of energy implementation, now you want to propose high cost flood. So you have to show EEI and baseline for the past 2 or 3 years, and then show the current EEI and baseline showing that there's no improvement after 2 or 3 years. Now you want to, since top management has capital and they want you to increase the energy savings further, then you might want to introduce high cost. So kena tunjuk bukti-bukti ni lah, EEI baseline from previous years, and then move forward. Ni soalan ni nanti most probably orang nak decide how your mini project will be assigned. Okay, and then of course this data need to be supported lah, EEI and baseline from the data you collected, which is this the last table tu. And that one is the energy year by year for each EAC. Okay, and then then we look into what kind of equipment that you might need to make sure that your audit process runs smoothly. So it depends on the item that you want to measure. If it's motor, then you might need multi-power meter, power analyzer, and strobo tachometer. If you haven't had any kind of this equipment, don't worry. You can just rent it out. If, let's say, for example, in the future, you set up your own management consultancy or ESCO, your own ESCO company, then all this equipment can be rented out actually. Of course, in the long run, it will be expensive, but the first few years setting up your company, you can rent it out. And then for illumination, basically you want to measure the lighting for that area, whether it's efficient or not. Then you need to have illuminance meter. If you want to measure airflow, and then ni lah equipment lain kena baca sendiri. So it's, I guess, most of these items that have been listed here isn't actually something that you would use typically day to day, except for multi-power meter lah. Maybe for electrical engineers like me, I'm quite familiar with multi-power meter, and also of course your netbook computer and digital camera. Yeah, multi-channel data logger for me as an electrical engineer, yeah, most probably yes, but for you guys most probably not lah. But all of this can be sewa, can be rented out by other companies. Itulah. Once you have established your company, later on might as well you buy it to help you with your businesses later on. So this is how it looks for hygrometer, lux meter. Again, lux meter is to measure the lighting dalam bilik. Hygrometer to measure the humidity and temperature. And energy analyzer, flow meter, ni semua baca lah. Yeah, most probably if you're not involved with auditing process, even if you have your own energy management company, most probably tak jumpa pun benda ni. Tapi starting out, I guess, mula-mula nak tak nak kenalah. As a owner, korang juga kena buat auditing. So ni lah equipment yang korang akan main nanti. Okay, this is client information survey, basically for the client to fill up for you to perform your data, desktop data collection. Desktop data collection. So you might as well ask them to fill this out first before you start your data collection processes to get the basic data for their company. And then EPC, EPC tadi energy performance contracting, bukannya energy performance apa. Tadi yang saya blur sekejap tadi tu, ni EPC ni. Ni lah yang saya kata EPC yang mana the client will not have to fork out their own money, but they engage the ESCO so that the ESCO will front the money to purchase the solar panel, And then for a period of time, ada gambar ni. Okay, let's say this year electricity bill 100,000. For a period of time after dia dah pasang ESCO tu dah front the money and pasang solar panel tu, so 20,000 ni dia ambil daripada payment electricity bill. That means every month you're still paying electricity bill even though dah pasang solar panel, you're still paying 100,000 until 5 years. Let's say lah contract kata 5 years. And after 5 years, then this saving will be returned back to the owner lah. Maksudnya owner tu dah tak payah bayar bill 100,000, dia just bayar 80,000 je. Nampak sikit memang. Tapi since you don't have, tak perlu keluarkan duit awal-awal 5 tahun tu, so you got nothing to lose lah. Because if you don't implement it, nak tak nak, you have to pay 100,000. In fact, apparently dapat tahu harga besi naik, harga minyak naik, harga arang naik. Dalam tahun depan, most probably harga electricity naik lagi. So not only you paying 100,000 if you don't implement this, now you have carbon tax, and then barang naik, harga barang naik, so menyebabkan your electricity bill akan naik. So you most probably will be paying 120,000 next year or next 2 years once those taxes be implemented and harga barang naik lah. So if you implement solar panel now, in 5 years time, harga barang naik macam mana pun, carbon tax macam mana pun, you still most probably you pay 120 for the 5 years yang sementara tunggu tu. But after dah habis 5 years tu, now you reduce to 80,000 instead of 140 and 50 after the 5 years tamat. Which is significant lah for a company. So memang nampak macam 5 years nak tunggu lamanya. Ya, betul. Tapi you have to consider, you haven't paid up anything up front to pay for the solar panel nak pasang tu, which may cost almost $1 million depending on the size of the building, energy consumption being used. So it may cost almost $1 million. So now you don't have to pay anything except once dah implement, you still pay the same electricity bill even though dah pasang solar panel up until 5 years, and then after that settle bayar. So you only bayar 80,000 and also the maintenance of the solar panel. Okay, all the other parts here is just reading, so you just read out through it. So 10 o'clock, I want to just power through lah. So basically, what does it mean by EPC concept? You don't have to pay upfront for the solar panel, and then for 5 years, according to the contract, depend on the contract, you're still paying 100,000 even though solar panel dah up, because 20,000 belongs to the ESCO, and electricity bill still need to be paid. But after 5 years, that 20,000 belongs to you, and your electricity bill is 80,000. But now you don't have to worry about rising cost of electricity and also carbon tax lah. If I'm not mistaken, carbon tax will be implemented for those companies who exceeded certain amount of carbon emitted lah. That one will wait in the few months or few years while they studied it. Of course, biasalah menteri dia kata hari ni study, tak silap 3-4 tahun lagi baru lulus Dewan. Itu pun kalau tak ditendang balik. Tiba-tiba tukar government ke jadi cerita lain pula, who knows. But at least the possibility is there, because once they have tabled the proposal, yelah, orang nak bagi, ada possibility nak duit, awak sendiri pun ada orang tahu ada orang nak bagi awak duit, takkan awak nak tolak kan? Mesti dia nak cari juga. So they can manipulate the proposal, dan konon-konon tendang sampai dia menang PRU, and then once dia menang PRU, implement lah. Beli apa dia? Dapat duit dah kita lah. Siapa nak bagi duit kita, nak tak nak, kita nak je. Cuma tak nak tanya lah, mana datang duit tu kan. Okay, ni the same thing. You don't have to upfront the cost. Owner boleh continue their business as usual. Just bayar, sebab kalau ada solar panel ke tak ada solar panel tu, for them they still have to pay the electricity bill. And then everything falls under ESCO, maintenance ke, financing ke, installation ke, semua ESCO yang settlekan. Owner tak payah pening kepala, dia boleh continue dia punya business macam tak ada solar panel until 5 years. Sedar-sedar dah ada solar panel dekat dia orang punya department, dah boleh save RM20,000. Dah boleh masuk poket dia, boleh beli kereta kabinet Livina, Velfire yang Menteri Kewangan nak beli tu. Okay, and then all equipment installed become the property of the owner once the contract period finished. So up to them lah. So tak perlu keluar duit, tiba-tiba dapat. Okay, so these are the references that you could use to see to help you with your proposal later on for your mini project in case you want to look at it. And I guess that's all for today. And we are finished at 10 o'clock and I don't want to extend more because nanti korang pun most probably ada korang punya apa nama kelas lain juga kan. So I guess I'll stop here. Again, if you have any question, please feel free to do so in class ke apa ke. But for today, I guess we'll stop here and kita sudahkan session kita